Oh, no.
Oh.
Wait, pause.
Get ready for the
I don't think wasting time is the answer to this question. So I'm gone on Monday, which means there's no one that's going to be able to help you with the math on Monday except yourselves. And I'm going to tell the sub that you are not allowed to say anything for half of class. And if you guys are silent for half of class, then you'll be able to work in groups for the second half of class. That is my direction, especially with younger classes. They aren't serious all the time about that. So to that end, you're going to be on your own for half of class on Monday. And then you're going to be able to work with others in a productive fashion for the second half of the class if the sub thinks that you have been wise and you have been careful. Now, what does that leave us with? Today, I need to go through chapter 10, 10:1, 10:3, 10:4, which is half of a normal chapter, right? You usually have 6 sections, that's only 3. So I think it's manageable. I'm going to go through every section of your chapter review. 10:1, 10:3, 10:4. And I'm going to do at least one even of every type of section. Now hold on, pause. Evens, I don't usually require those on reviews, right? What are evens? So what you're going to do today, in your notes, is write and work out the evens with me. Then, when you go to work on your review, this weekend it's homework and Monday it's homework. So could you work on the review Monday in class? Yeah. You're going to be doing the odds for your homework, and couldn't you be looking at your notes and writing down the evens that we're going to do together today and end up with bonus at the end? Yes. Does that make sense? So I'm not going to be doing the homework problems, the odds with you. I'll be choosing an even from every section, so at least 3 evens, but I might do a couple if there's like different directions for each. We're going to go through each type of problem that'll be on the test on Tuesday. We're going to go over each type of problem that might be on the test on Tuesday. We're going to start with the review. I'm going to make sure that we go through 10:1, 10:3, 10:4, and even at least one from each of those sections, maybe more than one. Jay, has it been your phone off, or the do not disturb, or the why are you scrolling?
Oh my God. I'm trying to lift it up.
Oh, okay. I've done it. You're in the restroom. Get your headphones on, because I said anything I see on TV. So then coming back, let's work through the evens. Let's get them down in your paper. They're not going to go on your homework paper, even though some of you guys are writing it down. That's a great idea. But we're going to do this in our notes, because I want you guys to write it with me today, work on it with me today, and then put it in order as you're going through your review. That way on Monday, when you guys are in the section where you're like, oh, I have to do some odds, and you have some time in class to work, you'll have the even you can go back to. So you'll do number 1, go back, write down number 2. Do number 3, you see what I mean? So you'll have some of it already done and we'll work this way. Now, if there is extra time at the end of class, we will go over homework questions from homework 64 and 63. You are turning that in today, but, let's get through the review first, because we will end with problems like homework from last night. Does that make sense? And then we'll have the review, kind of at least a snapshot of the review done. Then I can go ahead and after doing that last or finishing that last example, I can follow that with, all right, now, this last problem, we just tried it, we just did it, and it's entirely like what the test might have. Now let's go over homework questions. So, homework 63 and 64, have it out, have it closed. Notes open, this is called the chapter 10 review. You have me today, you don't have me Monday. Monday you're going to have someone who's going to keep the discipline and keep you guys, remember, silent for half, earn being able to work together for the second half. Okay? So do you have to finish the whole review this weekend? No. So some of you could catch up on homework if you've fallen behind, right? And you could go back over the homework that we've done, which I think should be 59, 60, 61, 62, 63, 64. 2 homeworks from every section, 10:1, 10:3, 10:4. All right? So if for any reason you fell behind this weekend, use it to catch up. Maybe start the review, but you will have all Monday in class to work on the review. Once again, half the class by yourself, no matter what, everyone. And then you can go ahead and ask each other questions for the second half, only if you earn. Quick question, shortly.
Wait, so that's all due on Tuesday, right?
Do on Tuesday to be the test. Do on Tuesday.
Are we going to ask ourselves questions if we were?
depends on how you're behaving. So it's not a bad idea. The sub might be able to, it's probably gonna be reading those numbers, but,
What's in your bucket?
or, you know, like, I don't know who they're gonna bring in, so they could bring in multiple people. Angels. I'm gonna expect complete respect. I'm gonna expect you guys to be like, hey, wait, chapter 10, only 3 sections. We've gone over a lot of it and a lot of examples. You guys can do this. But you're gonna have to work and study on Monday to do well on Tuesday, okay? Kiddos, let's go ahead and go through the review. Ready? You might have already written this down on a homework paper, but we are going to the section itself. 10.1 is where we started. 10.1 is where we started. 10.1, we talked about how to graph square roots. Now, I'm not going through and like having us do all these examples. I'm just showing you a couple things before we do an even or two, okay? So, 10.1 shows us a function with a square root. Remember, square root is the name for the radical when there is an index of 2, when this index is missing. If we are trying to find the domain, in your notes, might actually be a good idea to go back in your notes. In your notes, we said in order to find, I'm going to write it right here, in order to find the domain, we take, for domain, the radicand, which is the expression underneath. Does anyone remember what do we do with that radicand? Said it? Greater than or equal to 0. Set the radicand greater than or equal to 0. So do you guys see how they took x plus 2 out? And didn't they set x plus 2 greater than or equal to 0? So guys, remember the very first step to anything with graphing a radicand was to find a domain. Because once they found a domain, which they did right here, once they found a domain to be greater than or equal to -2, then their goal was to graph. Now I would have told you to start, if you guys notice, isn't the next problem another function? Okay, it's another function, so it doesn't work quite as well. But I told you guys to start your table at the domain. So for letter A, if we needed to graph letter A, where would our table have started? Good. Our table would have started at -2. And why would it have started at -2? Because that's what our domain told us. Now, would I have gone numbers higher than -2 or numbers lower than -2?
Higher, so it's greater than.
Yeah. There's a test on Tuesday. We're paying attention. Get that out of your mouth and stop talking to people constantly. People on this side, the same goes for you. So, plugging in -2, we would have gone higher than -2 because what's our inequality? Greater than or equal to is our inequality. So we go higher. So let's look at letter B. What is the domain for letter B? What do I set greater than or equal to 0? Who's under? Just x. So for the domain, we would have gone ahead and said, let's take the radicand, and who was in there? X. Let's set that greater than or equal to 0. Well, do I need to move anything, or is x already 1? So where did we start? 0. Why did we go up? Because what does the inequality say? Greater than. Because the big mouth eats the bigger number, so x is greater than. He's the higher one. So we go up. Why did they go from 0 to 1, from 1 to 4, from 4 to 9? Why are they jumping so quickly? Because they're nice, easy ones to plug in. And then last but not least, how are we supposed to find the range? Why is the range of this one, which is the same thing as this graph right here, why is the range y greater than or equal to -1?
Look at this one.
Good. How low does it go?
On a test, can you set the transfer line first, and then you open the graph? On a be on the test, like that, and if after can we set the platform first and then can we do that? Three course hours, she plays on each of your verification. Can we just do that?
Oh, the parent function, is that what you're talking about?
Like, can we, on the test, can we set it and then like move from there?
Yes, unless I say from. Then you could always do that first and then do the table and make sure that. So then let's go and do even. I want you guys in your notes to write down number 2. Actually, let's just go straight to number 4. We'll do the hardest one. That's okay. I'm trying to help you. Let's do number 4 first. Okay? So number 4, we're going to do all sorts of things. Okay? We're going to figure out the domain and the range. We're going to graph with a table. And then we're going to compare. Compare. What?
Does it say 1/4?
Yeah, sorry. 1/4. Square root of x minus 6 plus 2. Okay. So we're going to start one piece at a time. I told you guys to always start with domain. What about x minus 6? That is called the radicand. What do I do with x minus 6? Good. Domain, I take whatever's underneath the radical. In this case, it is x minus 6. And I do greater than or equal to 0. Greater than or equal to 0. That's in our notes. Radicand greater than or equal to 0. Ava and Jay, make sure we're tracking.
So you pull the radicand, that's it, greater than or equal to 0.
And then it's time for me to solve. So then on this side I have x, I have my inequality, 0 plus 6 is 6. So I'm going to say for my domain, and actually come over to the side to show my answers, kind of like you guys do in the test, right? Come over here to the side. We'll say x is greater than or equal to 6. Okay. However, after we find the domain, to find the range, we need to graph. We need to graph. So then we make a graph. Well, first we make a table to make a graph. We need x's, we need f of x's. Kiddos, based on the domain, what number do I put in first? 6. Now, look at the inequality. Am I going above 6? Dylan, you right, buddy? Remember, these are ones you can write down. Literally, I'm doing some of your bonus homework for you. I'm going to go up. How come, Jen? Good. So I'm going to go up from, I'll just say from right now, I'm going to go from 6 to 7.
So where are you going?
Because greater than or equal to means go higher. Greater than, higher. Less than.
But so it's facing the same thing.
So then if I plug in 6, remember plugging in takes a little bit of work, especially when the function is kind of big and nasty like the one up here. We're going to go ahead and carefully say, okay, for this one, plugging in 6, I'm going to do 1/4 square root of, what is? Remember where we plug it in?
6.
Plug it in here. What's 6 minus 6?
0. So
Good.
it's just 1/4.
Now hold on, wait. Don't forget to write the plus 2, else you're going to get lost a little bit.
Oh, yeah.
So 1/4 times square root of 0 is 0. 0 times 1/4 is 0. 0 plus 2 is 2. Okay? Why was this one nice? Because we know the square root of 0. How about the next one for number 7? Or for when x is 7?
Square root
I
of
have
1 is 1.
what's 7 minus 6? You guys see where I'm plugging into, right?
Yes.
I'm plugging in right up here to the radicand. Square root of 1, I can do, right? What's the square root of 1? 1 times 1/4. That's just 1/4. 1/4 plus 2, 2 1/4. Could I write that? Yeah, I suppose. Could I write 2.25 if you guys like decimals? Yeah, I suppose. I'm going to do 2 1/4 just because we already have that written. Because that's what the answer was. So this one was 2. This one was 2 1/4. Does that make sense? Now, we probably should get at least one more point just to have an idea. But why do I not want to plug in? Someone's saying a number and I agree. I don't want 8. I don't want 9. Why? Look at the radicand. What is 8 minus 6? Do I want to do a square root of 2?
No.
What is 9 minus 6? I don't want square root of 3. How about 10 minus 6?
4.
So I want square root of 4.
Yeah.
This just makes it easier so that we don't have as many decimals. I am going to go to the end next. I kind of try 7. That's okay. 7 minus 6 is 1. I know that's square root. 8 minus 6 is 2. I don't know that's square root. So I just kind of skip all the way to 10. So when we go to plug in 10,
And it's going to be
I'm going to have 1/4.
1, 4, 2.
It's not good in there. So you guys are already there. That's good. Let me just catch up. Okay. So I have 1/4. Square root of what was 10 minus 6 again?
4. That is 2.
Plus 2. Good. Square root of 4 is 2. 2 times 1/4 is,
1 per half.
yeah, 2 times 1/4 is 1/2. Is it's 2 over 4? We'll end up with 2 1/2.
Yeah.
So then 2 1/2 is my next point. So, okay, we at least have some stuff to make a graph, right guys?
Yeah.
So let's go ahead and make a graph. I'm going to draw way over here, 1, 2, 3, 4, 5, 6,
Yeah, we just said the parental
7,
function.
8, 9, 10. You could do the parent function if you would like. Technically, you don't have to start there because our first direction was just to graph what we have. But if you did want to do the parent function, you could. The parent function would be square root of x. So if you want to think about what it should be originally, that would be 0, 0, 1, 1, 4, 2. That would be the parent function, which is just square root of x, all on its own. I need to put a little tick marks to make 1, 1, and 2, 2. Sorry, 4, 2. However, we're trying to graph the one that we have in our table, and our table says, okay, we start at 6, 2. That's our first point. What's the height at 7? 2 and 1/4. Oh, stink. 1/4? That sounds kind of hard, right? If I was to make 1/4, that's a half. That's a fourth and 3/4. Okay. So let's zoom out again. So I have 7, 2 and 1/4. That's just a little bit above. Then I have 10, 2 1/2. That's just a little bit above. It's not even very curvy at all. Remember square roots? They go forever in how many directions? Just one. Just one. So I start from the beginning point, I go to the end, and I draw a little arrow.
I thought it was like one big one.
What we showed is Rob was bringing up the parent function because in just a second we're going to have to describe the transformation. We're going to compare the one that we drew to what a normal square root function looks like. So that little yellow one is just to remind us what a normal one looks like. Okay? Now, kiddos, to figure out what a normal one looks like, if we draw the parent function, we can probably say a couple things like, do you guys see that the red one shifted? How did it shift? How can we describe? Yeah, g of x shifted 6 to the, what direction did it go 6? Instead of saying 2 though, we'll just say 6 right. And, was there another shift? Yeah, how much up? Can you tell how many tick marks? 2, yeah. And 2 up. So you can say that g of x shifted 6 right and 2 up. There is technically one other transformation. But in order to get that one, we probably would need to look at that table that we talked about in section 10.1. If you guys have your notes, you might want to turn there, or if you just want to look at the table, I'm going to pull it up. We're looking for what else happened. We got that it shifted 6 right and 2 up, but what else happened? Well, let's go ahead and go look at that table really fast from section 10.1. I'm going to write the function once we get to the table, and we'll try to compare it. You can look at my table. The function that we're looking at, you don't have to write this in your notes, but the function is 1/4 x minus 6 plus 2. First of all, let's see if we can figure out our shift. Okay, let's see if we can figure out our shift.
So are you using that equation on the top right?
Uh-huh. Do you guys see how we got the shift of 2 up? there was an addition by 2, and that fits it in the addition category, vertical translation. And the wording over here for vertical translation, whenever we have a number there, is shift up, right? So shift up by 2. Then we have the -6. Can anybody match? There's a -6 on the inside of the radical. What is that called? Yeah, the top one, right? So what's going on in the top one when we look at that and there's a minus under the radical? Shift right. So we have a shift up, we have a shift right, but what's the one thing that we haven't talked about? We talked about the +2, talked about the -6, we have the shift up and the shift right.
The numbers that is outside the.
Yeah, which one corresponds to a number being multiplied on the outside? Rob?
The last one.
The last one.
The last one, good.
And it would stretch. No, shrink.
It would shrink. Do you guys see how there's a fraction in that one?
Yeah.
So if we look at that fraction, we can say there's going to be a
So
shrink.
it's like a normal number, like 4 or 5 would be.
So we can say there's going to be a, we want to be super snazzy, a vertical shrink. A vertical shrink by, and we'll use the number that's there. So we already figured out just by looking at the graph, because Rob has graph the parent function. Since there's a minus on the inside, we can say there's a shift right by 6. Since there's a plus on the outside, we can say that there is a shift up 2. And then last but not least, since there's a 1/4 on the outside, we can say there's a vertical shrink by 1/4. So I'm going to go back to our example. Guys, once again, I gave you the hard even in 1 through 4, where you also had to use these comparing words with shift and with stretch and shrink. So we almost got it. We have our -6 on the inside that we already got, shifted 6 right. We have the +2, which we already got, 2 up. And last but not least, we have the 1/4. So we're going to say and a vertical shrink by 1/4. Now, we want a good test on Tuesday, right? Since we want a good test on Tuesday,
Yeah.
I don't mind if you guys think it would be helpful you writing that table, which is in your book and in my notes online if you didn't get them in your notes. You can write as much of that table, including the examples, as you want. That's the only thing that's allowed to be on the card. It can be a half sheet of paper if you don't have an index card. It could just be an index card. All you're allowed to write down is that table as much as you want of that table. Okay? And you're allowed to have that for the test. When do we use that table? When they tell us to describe the transformation. But another way that they can tell us is when they say to compare. If they say to transformation or compare, then you're using these words. Now, Jordan, I'm going to answer your question in just a second. I actually need to finish the problem though. We've done the domain. We've done the compare. We've done the graph. What's the one underlined without a check mark?
2.
No. What's the one underlined that we haven't done? We did.
Range.
Domain. Domain is radican greater than or equal to 0. Those are x's. Range is what?
Y.
Y's. And y's are how low does it go? Or how high does it go? So check it out. How low is our function on the y's? How low does it go? Right? The lowest it goes is 2. So we're going to go ahead and say if that's the lowest that the range goes, we can say range y is greater than or equal to 2. It is not 0 because remember our function is the red one, and the red one doesn't go below 2. You can see 2 is the lowest it goes, and it's only going to go up from 2. Yeah, the yellow one, remember that's a different function. We were just using it to compare. Alright, that's 10-1. That's like a huge, nasty, big old problem from 10-1. So question. Do you guys see how there could be easier questions or shorter questions from 10-1? Could I just ask the domain? Yeah. And for domain, wouldn't you take radican greater than or equal to 0 and so? Could I give you maybe a picture or have you graph and find the range? Yeah, without comparing. But if you're gonna graph a radical, what do I always want you to do first, no matter what? Do the table, and to do the table, you always start with domain. Range is how high, how low, we've done that now. Graph is from the table. And compare, what are you gonna put on a half sheet of paper on an index card? The table. Is it in your book?
Yes.
Yes.
They listed.
In what section?
Yeah, you just said. Use it for the test.
You can
Okay.
you write 5 cards or a half sheet of paper. You're only allowed to write the table, but you can write as much of that comparing table, including the examples as you want. Okay, guys, 10-1, we're 1/3 of the way done. Go fast. We need 10-3. All right, kiddos, let's review 10-3 real quick. 10-3 wasn't graphing, happens done. 10-3 was solving. We were trying to solve, well guys, hold on. Stop, look at the very end. Who are we solving for? What are we trying to get along? X. But to solve for X, what did we have to do?
Square.
And how do we get rid of the radical?
Square.
Square both sides. Careful. How do you get rid of the square root? We square, we square. We square both sides. What happens if they did not show? What do I always do that they didn't show right here? What happens once you put the square in? They cancel out, and what is left? Just the inside. Just the inside. The radical is now canceled. I'm going to go ahead and show that. The radical cancels. And you can cross out the radical. The radical cancels. 10 minus 3x stays. Now, how did they go from this step to this step? Sometimes it's hard to follow the book. How did they go from the step with 10 minus 3x to here? See it?
Just put it all equal to 0.
They moved these two terms to the right side to get it equal to 0. Now, how would you move a positive 10? You subtract 10. Does this one end up being negative? How do you get rid of a minus 3x? You add 3x. So they subtracted 10, they added 3x, subtracted 10, added 3x. Now, how did they choose to solve? They factored. They said, what factors of 10, if the last sign is negative, the signs they must change. They knew a negative and positive. Yes, well, or both negative, the signs stay the same. Maybe positive, maybe negative, negative. So then 10, if we think about the factors of 10, 1 and 10, can that make 3?
No.
2 and 5, 2 and 5 can make a positive 3 if I have a plus 5 and a minus 2. Factoring was easy on this one, easier than some, but can I just really quickly ask you guys, is there another way of solving? You have to have something memorized, but is there another way of solving if you're not so good at factoring? Yeah, we could say that A is equal to 1. What would B equal? What would C equal? Okay, do you guys remember the formula?
Yes.
X equals,
Negative 3.
wait, what's negative 3? Oh, just negative 3. Plus or minus?
Minus 4 is 3 minus square root over 2.
Now, what I'm trying to show you guys is whether or not the quadratic formula could have also solved. Now, this one, factoring was definitely the easiest. Factoring was definitely the easiest. Factoring was definitely the easiest. But we still have to, if we were to do the quadratic formula, sometimes it's the only way to go. We would need to simplify it. I'm going to go pretty quick here. But 3 squared is a 9. And I have negative 4 times 1 times negative 10. What's negative 4 times negative 10?
Positive 40.
40. What's 40? Positive 40 plus 9?
49.
Just in case you see a nasty one on the test. You're right, the square root of 49 is 7. How do we finish solving this with the quadratic? No, there are two answers. I need two answers, not just one.
First one, you plus 7, 5, negative 5, and
I need to add 7, but I also need to subtract 7. So I have negative 3 plus 7 is 4, over 2 is 2. On the bottom, it's okay. Click on the back. Negative 3 minus 7, negative 10. Negative 10 over 2 is negative 5. Now, does that match up with what factoring got us?
Yes.
Okay, so factoring works because once you factor, set each equal, and you solve, the quadratic formula works also. But which one do you think would you make more mistakes on? Just naturally? Some of you would make more mistakes here because once there are lots of numbers, you get confused. But some of you make mistakes here and you don't check every time to make sure your factors are right. So you need to figure out which one's better for you.
Well, Robbie's doctor left him
Hopefully it's back soon. So otherwise you might try to. Okay, here we go. So let's go ahead and wait a minute. Whoa! Why are they checking in this section? What was the point? Why was it important to check? Yeah. Make sure it's not false. What was the need for those false solutions where you think they're right?
no,
Extraneous. But wait, pause. Isn't it true that extraneous ones are the ill? Angel, it's okay. And whoever's like, guys, we're doing so well. Hang in. Extraneous is the word for the illegal ones. Calm down. Compose yourself. Extraneous is the word for the illegal ones. Will we know they're illegal from the math? No. When will we know if they're illegal or not? Angel. We won't know if they're illegal from the math because they sneak in with the math. When we put the squared over and the square root goes away, sometimes the illegal ones come in. But we will know from the checking. And like Caleb said, if the checking is true, it's good. Keep it. If the checking is false, what do we say? Throw that one out. Throw that one out. Alan, I've asked you to stop. I know that you're trying to be funny, but now's not the time. Let's go ahead and come on down. Are you done? Keep on the back. So let's go ahead and do, for sake of time, let's go ahead and do, I don't know, what do you guys think looks like the nastiest? It has to be even. 10, 12, 14.
I think
14's kind of big.
10's too easy.
12? 12 is
Yeah.
square root on both sides.
No, I think 12, yeah, because there's 2 square roots. So it's going to be 12.
Okay, so we're doing number 12. Can you guys just help me out though? On 14, where would you have started? We're not going to do the whole thing. We'll do number 12.
subtracting 34.
You would need to subtract first. I'm not solving all of this one because you guys did ask for a different one, but I just need to make sure that you guys know how to start. You would have 24. Johnny, how would you keep going?
Divide.
Yeah.
Divide 8 to both sides.
Well, we can't just get rid of something. What do we do to both sides to get rid of the square?
Squares.
Yeah. So when we square this side, the square root does go away. But pause. What do we have to not forget on the other side?
The other square. That's going to be 9. X minus 5.
You guys just want to finish this up.
9.
That's what the answer is.
5.
X equals 14.
That's going to be 14.
Now pause. Wait. Why do they say check? We gotta make sure it works.
You gotta make sure. So
You
you
gotta make
have
sure it
to,
works.
it might be extreme.
It might be extraneous. So check. Remember for check, we gotta take what we see as x. Come on. We gotta take what we see as x, we gotta plug it in. So 8 times the square root of, plug in 14 where the highlighter is up above, plus 34. It needs to equal 58. And as Caleb said earlier, true or false? I'm trying to see true or false. False. So then, what do we need to do in order to solve? What's 14 minus 5? 9. Now hold on, what is the square root of 9? Do we know that? 3. So we're gonna go ahead and plug in 3. What's 8 times 3?
24.
What's 24 plus 34?
That's
So that means this is true.
True.
So since it's true, what are we doing? We're keeping it. We're saying, oh yeah, buddy, that's right.
It's not extraneous.
Not extraneous.
I thought if you actually, if it's only a negative, I thought that's what was extraneous.
But not if it's a negative number. Not if the answer, Caleb, is negative, right?
Yeah.
Only if you get like a positive equal to a negative, then we say it's false and we have to say no. Now hold on, Kaylee was asking, I think a couple others were as well, that you guys didn't like number 12 because there were 2 square roots.
I don't like that.
Oh, yes.
So I'm not gonna go ahead and, hold on, I'm not gonna solve the whole thing because we did do all of number 14. But I am gonna make sure that we know how to start. Justin was explaining and reminding us how to solve. Justin, why are you saying to square both sides?
Because we have square root. You gotta get rid of it.
The radical is already alone.
Oh,
There is no moving stuff around. The radical is already alone on one side and on the other. Did you get that clear? So therefore, if we square both sides, what happens?
the square root.
Get rid of everything.
And what do we end up getting?
5x minus 9 equals 4.
You guys think we can finish it quick and still have time for one more
Yeah, it's
example?
pretty easy.
Okay, so then how are we gonna keep going?
Well,
Plus 9 is equal to
Well,
Hold on, pause, I'm gonna go.
you have to isolate or leave the isolate.
Yes, yes.
Divide? Oh, I wish.
What?
Do you see how there's x's here
Oh,
and
it's
here?
so yeah, it's like 5 under. I don't know how to explain it.
subtract by 4.
Oh, do you wanna move the 5? We can move the 5,
Yeah, I
hold
was
on,
doing the
pause.
5.
Move the 5, okay. No, you can move the 5. So move the 5 by, just double check, Ian, you were subtracting, right?
Yeah.
Good. So then on the left side, what do you have still over there on that side?
Negative
What do you have now on this side?
Negative 1x.
How are
Then
you
you
gonna
divide
solve?
by
You
negative
divide by
1.
negative 1.
And it's not like
It's gonna
x
be
equal
9.
Yeah.
Now, hold on, pause. I'm not gonna box that answer until I what?
Check, check.
Okay. When we check, what do we do? Okay, good. But what do we do with the 9?
That's extraneous.
Plug it into both x's. So we end up with square root of 5 times 9 minus 9
Oh, yeah,
equals square root of 4 times 9.
45 minus 9.
What is 45 minus 9?
That's the question of the year.
What?
Wait, what?
Minus is 36.
36 versus
That's 6.
But wait, what's on this
Plus
side?
6 is 12. And it's on this side.
That's true, right?
Right?
Okay, pause. Some of you guys are guessing they're extraneous. I'm just saying check it to
They're
see.
not.
You gotta
It's
check.
equal 6.
Not every answer, it's okay, not every answer is extraneous, but can I guarantee that probably at least one will be on the test? Yes. So you have to check. But I will remind you, and I'll say check on the test, okay? We gotta get to section 10.4. This is the last section. Okay. We just need to focus. So then, section 10.4, the last one, inverse of a function. Long story short, we just did this one, so I'm not even gonna go over the review, I'm gonna go straight down to where we might have had issues last night,
Oh, yeah.
okay? First of all, number 18 and 17, but we're just doing the evens, right, Johnny? For number 18, question, how would we make a table for the inverse of the table in number 18? No, it's not exactly the same. Something changes. What happened? Switches. The X's and the Y's switch. So, Dylan, focus straight away. Caleb, focus straight away. So instead of having the point -4, 6, what am I going to have for my first point? Instead of having -2, 3, I'm going to have
3 over 0.
Negative 2.
0, 0, 2. Yes, for sure.
Does that make sense?
Yes.
Okay. Now guys, that was number 18, that was the easy one. That's 20, so you gotta get to number 20, okay? So for number 20, we need to go ahead and follow our steps. And let's see if we remember our steps. For number 18, all we had to do was switch the points. For number 20, we had to first set f of x equals to y. That's step number one. Now guys, remember, this is just what makes it legal. Don't stress, this is what makes it legal. X greater than or equal to 0. Step 2. Come on, help.
Switch
Switch
Oh,
that to
it's
y,
actually
and
y.
the rest that follows. Step 3.
You add one.
What am I doing though?
Solve the question.
4.
Why?
I'm solving for y. I'm solving for y. I'm solving for what used to be the input. We're switching them, right? So yes, I'm gonna add 1.
Yeah, one.
So I'm gonna have x plus 1 because I can't combine. A few of you get stuck on that.
Oh yeah,
Be
I
careful.
forgot that.
And
Then I divide by
3.
Plus
Wait,
nine.
is that 3y squared?
yeah. Now there are two ways of writing this. We could write it as x plus 1 over 3, or we could write it as x over 3 plus 1 over 3. That would have made graphing a little bit easier last night.
If it would, why would it make it easier if you have fractions?
Well, because if you have mx plus b, that's easier than having negative mx plus b. Okay, now I'm going to come back because this one is not a line, this one is quadratic, so it's not going to be the same as mx plus b. How do I get the y? I'm going to write the y squared on the left side because it looks a little nicer. How am I going to get the y by itself? I need to put a square root. But when I put a square root in, I have to do a, whenever I put a square root, I have to think of a plus minus.
And you have to have two separate solutions.
Okay. Well, two separate equations, kind of. That's okay. So then I end up with y equals plus or minus the square root of x plus 1 over 3. Now, here's kind of the weird thing. We have to kind of go back. And this is what I didn't get to show you yesterday, and I apologize for that. It's just we didn't have time. You guys got distracted a lot. And the class was good though. If we come back up, x greater than or equal to 0 says x's can only be positive numbers. Says x's can only be positive numbers. As a result, technically, at the very, very end, we can take away the plus minus. In a sense, we're saying, you know what, we're only allowed to have positive. We're only allowed to have positive outputs. So technically, the best answer is not going to have a plus or minus. It's just going to have the positive. But that's really hard to see if you're not graphing. That's really hard to see if you're not graphing. Now, kiddos, to be honest, on the test, I'm probably not going to make you guys graph any quadratics. Because the directions say, find the inverse, which we did, but what's supposed to come next?
Graph.
Okay, it's supposed to say graph, but technically pause. Pay attention. I didn't say you don't have to graph at all. I said you don't have to graph quadratics. So since this one is a quadratic, I'm going to say that we're going to go ahead and skip the graph. So if any of you guys got stuck on quadratic graphs last night, aka the original function was or had a square, I'm going to say that we're not going to have to graph that on the test. But question, could I still ask you to graph lines?
Yes.
Linear functions? Yes. Mx plus b, y equals mx plus b. Could I ask you to graph a radical function? Yes. Because we learned how to graph radical functions in what section? 10.1. 10.1, the first section we learned how to graph radicals. So, hear me out. I can ask for graphs of radical functions, and I can ask for graphs of lines, but I will not ask for graphs of quadratics. Now guys, there is one more thing I need you to see in this problem from last night's homework. Once again, if it's a quadratic, I would not make you graph it, okay? There's one more thing they're going to change. Technically, they do not put y equals in the final answer. They say, you know what? F was the original function. F was the beginning function. If we just put a y in the end, it's going to look like it's the same y as the beginning. But question, are these two the same? No.
No.
They're related, but they're not the same. So technically, the final step is to call this guy by another name and say, okay, he's related. And I can technically tell you he's the inverse, but we're gonna name him G because that makes him separate from F. Kiddos, that is section 10.4. That is inverses of relations, meaning switch the points, switch the tables, and inverses of functions. Set F equal to Y. Switch X and Y. Solve for Y. And then name it G. There's technically one last step. Now kiddos, I want you to go ahead and, before you leave, you need to show me that you have a picture of homework 65. Now listen. Did we turn in 63 and 64?
No.
No. Listen. Keep them safe. I told some of you guys that if you didn't have them ready for today, you can have a little bit of grace this weekend, because what are you working on in class on Monday?
All of them.
The review. So have everything else done and up to date. Show me that you have the assignment and you may leave. In class on Monday, be good for yourself. And work on your review. Half the class silent on your own. Half the class you're working on your own on the review, then the other half you can ask those students questions. Good job. You guys can also work on having your notes up to date if they're behind. Good.
Silent, I'm loving that.
Keep
Oh,
on
yeah.
training.
Is that how you get all the girls?
Are fine.
Huh?
No, more than 25.
What was the question?
No, and they.
Yeah, no, that's good. No. Well, because there's time. Because Monday you guys can work on the review, so I'd like to catch up now. I can take homework if you're afraid of losing it. I'll put it. Yeah, that's okay. Hi, Misty. Did you see my text? Oh, no, I haven't gotten over that.